Dear students, welcome and thank you for tuning in. We are continuing our discussion about prototyping as part of the product design development course. In this video, we're going to talk about the principles of prototyping and what can we benefit from prototyping from a technical point of view, and how we are going to speed up or change the development process and the steps that we are taking in our projects. The first thing is we need to highlight the flexibility of analytical prototypes. So you can see these models in the pictures. Those are all analytical prototypes. We would like, before committing to these models and these prototypes, we need to make sure that we are making decisions about what type of prototype we want to build. And clearly we're going to go with the analytical prototype route. We would like also to see how to incorporate the prototype into the project plan, and how can we incorporate the efforts to create these prototypes in our plan. So mathematical approximation of the products, they are models and they contain parameters that can be varied in order to present a change of the decision on the alternatives that we are taking. So they're very important, and we care about creating those analytical prototypes. And it's easier to change the parameters here as opposed to physical prototype. And as we mentioned before, analytical prototypes should precede physical prototypes. So I would encourage all of you actually to start working on building your prototypes. And we need to make a decision if you're going to be doing something focused as opposed to comprehensive prototype. So we're sure that we are going through into the analytical route, but about focused as opposed to comprehensive, and we'll talk about this as we move on. We would like to also narrow the range of feasible parameters because using the analytical prototype and the physical prototype. If we were lucky to build it, it will be used to fine-tune or confirm the design that we worked with. And again, keep in mind, focused as opposed to comprehensive. Physical prototypes are important, and they exhibits unanticipated phenomena, because when we build our prototype, all the laws of physics and mathematics coming together in order to create the functionality of our product. So it's very important to produce at least one physical prototype in our project. However, we can design and produce multiple. We need at least one physical, but we can create multiple analytical prototypes. That's very important. And you can see in this image here actually how important the analytical prototypes and how sophisticated they have become actually. So we now can model car crashing, and we can measure most of the parameters that we want to measure just by simulation, and that's extremely important. Let's keep moving into and talk about the principles of prototyping. So we agree that we are going to focus on analytical prototyping, and the question was focused against comprehensive. So let's dig deep into the principles and see what we can pull out from this discussion. So one of the other principles of prototyping is reducing the risk of costly iterations. And that's very important. This is another argument of why we need to do prototyping. And this is a schematic representation of an example where we can show that prototyping reduces the risk of costly iteration. So this is if you're building parts and they're molded parts, and suddenly one of the parts is fitted poorly with its mating parts, one of the parts is poorly fitted, that's a big problem. So in manufacturing, we can say that if I have built an injectable mold and I have 30% probability of repeating the experiment and 70% of success, we are just doing, we have only 70%. That's a high risk actually. And measuring risk in manufacturing and product design development is an important aspect. We will talk more about it in the coming lectures. But let's assume that if we did this conventional way, we are ending up with 70%. So we have 30% chance of repeating the process. However, if you build a prototype, you are going to go with this 70 and 30% in the first iteration. And after building the prototype, it should be cheap, it should be quick. And after we do this, we are certain that it's going to work. This will increase our chances to 95% of success and only 5% of repetition because of the prototype. And that's what we mean by reducing the risk of costly iterations. And this is very important. So we went from 70 to 90% of success. And this is, however, reducing the risk must be weighted against the time and money required to build the prototype. So we need to keep that in mind, actually. One more principle that we can utilize is reducing the risk of costly iteration. We mentioned that, and we have a schematic that will map actually technical or market risks against cost of comprehensive prototypes. Again, we said we are going with analytical models, but we didn't say if we're going to go with focused as opposed to comprehensive. If you are going to comprehensive modeling, it's very important to keep in mind this chart that as the higher is what kind of products we can create using this chart. We would like to be in somewhere where we have low risks and low costs if we want to build comprehensive, and for the sake of our project and our class. So this is a presentation of what can be made actually. So writing a book, it's low risk, low cost, and it's comprehensive. So that's complete. However, if you have, creating a ship, the risk is low because the technology is there. However, you have a very high cost to do this. And if you are creating something that is high at risk and high in cost, like new cars and new airplanes, we should consider how are you going to be building your modeling and prototyping. So if you are in this area, usually the prototype made actually is sold. So it's very important to keep that in mind. I hope that clarifies what does it mean by trying to reduce the risk and weigh the risks with time and if you want to create your prototype or not. Another principle we need to keep in mind is that expediting other development steps. So let's say if the addition of short prototyping phases may allow subsequent activity to be completed quickly, and as opposed to not having a prototype. So you can say in this conventional process we have part design, mold design, and then mold fabrication. You can say part design, I can create a quick prototype, I can do mold design, and then I shorten the time to start the mold fabrication. If this is the case, then we go ahead and we create our prototype. If this is not the case, then we will probably not do this. One more principle of prototyping is that we can utilize, and its justification why we will use prototyping is restructuring of the tasks dependency in our process, in the product design development process. So it may be possible to complete some of the tasks concurrently by building prototypes. So if you have, let's say, a conventional process like this, you start with system design, PC board fabrication, software testing, and system assembly. We can, instead of doing the PC board fabrication as fancy board PC board fabrication, we can do hand board circuitry, and then we test the software. So you can do system design, you do prototype circuit board by hand circuitry and hand board circuitry, and then you test the software at the same time as you are building the PC board fabrication. So you are restructuring your development process, and this is going to cut the time, and then we're going to see in our following lectures how development time is important in making a profit for the products. I hope this comprises and explains the principles of prototyping and what you should be thinking of when you create your prototype. Thank you for watching. Until the next video. Bye.